Okay. Our next topic will be field of a dipole, that is electric field produced by an electric dipole, and we have two cases. First is axial point, right? First is axial point. For that, let's draw the diagram. You have a positive charge here and you have a negative charge here, separated by a distance of 2a, right? And this is the axis of the dipole. The black line shows the axis of the dipole, and we have to find the electric field produced by this system at the point which is lying on the axis of the dipole. So extending this line, suppose I have a point P over here, and at this point I have to find the electric field. Okay, now remember, focus on the diagram. This is the center of the dipole or center of mass, whatever you say. Its distance of the point is r, so that this distance becomes r minus a, because this is double of a or twice a, so this is a and this is a. So from r we have deducted what? A. Now this is another distance of point P from the negative charge is r plus a. Okay, clear? So we have got this two position of the two charges with respect to the point and the distance of that particular point from the two charges. Okay, now let's start the mathematics. What to do to find the electric field at point P? We shall treat the system as a combination of two single charges, as we have been doing. So first we shall find what is the electric field produced by this positive charge. So that is written as E plus, that is electric field due to the positive charge, is equal to what? 1 upon 4 pi epsilon naught the charge upon the square of the distance. Now what is the distance? R minus a, right? And obviously this field will be along plus to that point, right? This is the direction of E plus. Suppose this is point O, right? And this is A and that is B. And the direction of the field will be along BP. Along BP. Now electric field produced by the negative charge denoted by E of minus and equal to 1 upon 4 pi epsilon naught q upon the total distance, that is r plus a. R plus a whole square. And what will be the direction? Direction will be towards the negative charge. Electric field are of different nature if the charge gets different sign. So electric field will be P to A. Okay, so this will be E of minus towards P to A, that is along P A. What will be the net field at this particular point P? You must be guessing this. This is closer because both the charges are equal. So this is close to this point. Obviously this charge will dominate its field at this particular point, and this charge being farther away will be less than its field. So the net field will be the field produced by the positive charge and minus the field produced by the negative charge. But what if I do write the vector equation? Vectorially the net field will be the vector sum of the two fields, that is E, the net field, is equal to E plus plus of E of minus, right? This is the vector equation. Now in vector notations or equations we always put the sign of plus between the different quantity because they are vectorially added. Now remember, this is not vector quantity. I have only taken its magnitude. This is the magnitude. This is the magnitude. Now the field at P, E equal to, obviously this will be dominating because its denominator is smaller, remember this, and everything else is same. So E of plus minus E of minus, that is 1 upon 4 pi epsilon naught Q R minus A square minus Q upon 4 pi epsilon naught R plus A whole square. Now take this Q upon 4 pi epsilon naught out. Q upon 4 pi epsilon naught out, 1 upon R minus A square minus R plus A square. Take the LCM. So this will be equal to R square because minus A square, A minus B and A plus B, right? That's we have done. Now both terms having a square, so put the square over here. That is Q upon 4 pi epsilon naught, and this quantity goes where you know the solution, you know the simplification, that is R plus A whole square minus R minus A whole square. Just go and simplify this. So we will have Q upon 4 pi epsilon naught R square minus A square to the power is 2, and expanding this we get R square plus A square plus 2 twice A R minus R square minus A square plus twice A R. All the square terms gets cancelled. Q upon 4 pi epsilon naught 4 A R R square minus A square to the power 2. Now split this term. Along with, we can take the Q inside and divide or split this 4 into. This is Q set over here. 2 into 2. You got the 4. Now twice AQ equal to what? Dipole moment, that is P. So this can be regarded as P. So this is 2 P R upon 4 pi epsilon naught R square minus A square to the power 2. That is the net electric field produced by the dipole added axial point. That is twice P R upon 4 pi epsilon naught. Okay. This is the expression for the electric field at the axial point. Now, what if the side of the dipole is very, very small to that of the distance of the point from the center? Only we have to put this condition that A is very, very small. Then A gets away. If A is very, very small, then then A square is equals to 0 compared to that of R square, and we are left with P twice P R 4 pi epsilon naught. What else is left? This goes away, R to the power 4. 1 R cancels this, that is twice of P upon 4 pi epsilon naught R to the power 3. Right? This is the expression for the electric field. Now remember, for a point charge, electric field was proportional to R to the power 2, and for a pair of charges, this electric field proportional to R to the power 3. That is, E is proportional to what? 1 to the power 1 upon R to the power 3. Okay, we shall discuss in later on how the electric field falls sharply or less sharply for a point charge or a dipole. Now, electric field for a point charge is given by E equals to 1 upon 4 pi epsilon naught, the charge over square of the distance, that is E proportional to 1 over r square. Now we have two things to note down, that if we draw the graph, that is variation of electric field with respect to r. Remember, whose power is higher, that graph will be close to the origin. That is, this is of less power, so this goes this way, and this is E proportional to 1 upon r square. What for this? It will be closer, it will be more closer to the origin, but finally they will approaching to meet the 0 point, but at a larger distance. So this is the electric field, and that is r, and this is what E proportional to 1 upon r square. Now from the graph, what we get? Electric field for a dipole falls, reduces more sharply than due to a point charge at the same distances. Okay, so this topic is now fully covered. We shall have its equatorial point in the next section.